Hello there. Did you know that every second there's so many things going on in the biological environment? The water cycle, the nitrogen cycle, the carbon cycle. In fact,
Hey, Bill.
what's up?
Suppose someone didn't know what any of that meant. Is there a quantifiable number that you can measure all the ecological services that you just said?
Of course, in fact, here in Suburban Montgomery, it is estimated that the ecological value is. Oh, wait, I'm not supposed to say that right now? That's for the end? Sorry, you're gonna have to wait for later.
Bill Nye the Science Guy. Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy. Bill Nye the Science Guy.
Oh, hi there. Here we have a pond. It is part of one of the most important cycles in the ecosystem, the water cycle. We're about to show you an animation explaining the water cycle better.
The water cycle is powered by energy from the sun. Solar energy evaporates water from oceans, lakes, rivers, streams, soil, and vegetation. After evaporation, the water molecules go through a process called condensation, where it goes from a liquid state to a gaseous state, forming clouds. The clouds travel throughout Earth, and at one point or another, the water molecules come down as rain or snow. Once it reaches the ground, it undergoes a variety of different processes, including infiltration, when surface water enters the soil and flows into the bodies of water, runoff, plant uptake, evaporation, evapotranspiration, evaporation from plants, or fog drip. Some streams and rivers bring the water back to where it started, where the cycle starts again. Overall, some of the principal processes involved in the water cycle include evaporation, condensation, and precipitation. The water cycle is in a constant state of dynamic equilibrium when the rate of evaporation equals the rate of precipitation.
Wasn't that a great animation? In Montgomery, recently we've had tough rains. Come over here. As you can see, the ground is wet from the recent rains. This water will evapotranspirate through the soil and the plants into the atmosphere. In the atmosphere, it will condense and create dew and fog, and eventually this fog will build up and create clouds. Once the clouds get really heavy, it'll start to rain and go back into the ground. The ground will get wet again, and the cycle will go on and on and on and on and on. And that's the water cycle, my friends.
We interrupt our program to bring you this important message.
Hey guys, I'm Fax, and this is Fun Facts with Fax. Oceans are the source of 86% of global evaporation, with evaporation keeping the Earth from overheating. If there are no oceans, surface temperatures on land would rise up to 153 degrees Fahrenheit. See you next time on Fun Facts with Fax.
And now with Dr. Sachs with the nitrogen cycle.
The nitrogen cycle starts in the air, where nitrogen is present in its gaseous form, N2. Plants will next absorb the nitrogen. However, plants are unable to absorb the atmospheric nitrogen. The nitrogen must be converted into nitrogenous compounds. Through rhizobium bacteria, the nitrogen can be converted into ammonia, NH3. This occurs in the roots of the leguminous plants, and this step is called nitrogen fixation. Next, the ammonia will need to be converted into nitrites and then into nitrates, which is done by nitrifying bacteria. This step is called nitrification. Another way that N2 can turn into nitrates is when a storm is present and lightning is present, because lightning strike can cause N2 to directly turn into nitrates. The nitrates will then be absorbed by the plants to make proteins. After this, the animals could eat plants, or the plants could decay eventually. If the animal eats the plant, then it will eventually excrete some of the material. And if the plant is not eaten, then it will eventually decay, and both will lead to the creation of nitrogenous waste. The nitrogenous waste will then decay and form ammonia, NH3. This process is called ammonification. And then again, through nitrifying bacteria, the ammonia will be turned into nitrates, which is again the step of nitrification. Once it becomes nitrates, the nitrates can either be absorbed by the plants again, or it can go back into atmospheric N2 through denitrifying bacteria. This step is called denitrification. There are major reservoirs called sinks all over the world. These sinks contain a large amount of carbon, and some of these major sinks are from plant matter, terrestrial biosphere, the ocean, and sedimentary deposits. The way the process works.
We interrupt our program to bring you this important message.
Hey guys, I'm Fax, and this is Fun Facts with Fax. Did you know that forests store 86% of above ground carbon and 73% of plant soil carbon? In fact, trees can hold carbon for hundreds of years, and soil can hold carbon for thousands of years. Did you also know that oceans provide approximately 2 gigatons of carbon per year? That's all we got for Fun Facts with Facts. See you next time.
The atmosphere is less than 1% of the total carbon in the cycle. Carbon can be removed from the atmosphere through diffusion, which will then enter the ocean. However, the ocean can also release carbon back into the air through diffusion as well. Carbon can also enter the atmosphere through the deforestation, respiration, and decomposition of organic soil matter, aquatic animals, land animals, plants, and us humans. However, through trees, the carbon can also be removed from the atmosphere through photosynthesis. The two main ways carbon leaves the atmosphere is through photosynthesis and diffusion. Looking back into the water, marine deposits from the ocean activity can create limestone, which stores a lot of carbon. Limestone is the largest reservoir of carbon in the carbon cycle. The carbon is also stored in oil and gas, which is dug up for the use of gasoline and energy. The factories that get the oil and gas emit fossil fuel emissions, which leads carbon to enter the atmosphere once again. One key thing to remember about the carbon cycle is that the more carbon is being released than is being used up by the plants, which causes an increase in CO2 in the air, which is a factor of the global warming. We have a lot of animals in Montgomery, from insects to deer to birds to fish. All of these animals play an important role in the trophic system and food web of suburban Montgomery. Changing the population of one species can cause overpopulation or underpopulation of another species. The biomass that has the most energy would be the plants because they are the primary producers, and as one goes down the trophic system, only 10% of the energy is transferred. Through the light-dependent reaction and the Calvin cycle that take place in the chlorophyll of plants, the plants harness energy from the sun. Once an animal like the infamous deer in Montgomery eats the plants, the energy is transferred. However, only 10% is transferred because of functions like respiration and metabolism. According to the Department of Transportation, Montgomery had 775 deers in 2015 and 810 deers in 2016, and it continues to grow every year. Deer has become such a problem that Montgomery has formed a deer management program to deal with the population of the deers.
Whoa! Oh, dang. How'd I get here? Oh, looks like we have some plants over there. This plant is part of the Anthophyta. The Anthophyta can be broken up into two parts, monocots and dicots. There's 6 distinct features between monocots and dicots that make them different. 5 of them we can easily see by the flowers, leaves, roots, stems, and pollen grains. The difference between these two start at the very early stage of each of their growths, which is the seed. Some main characteristics of monocots are that the floral leaves are multiples of 3. Their seeds are just a single cotyledon, and they have fibrous roots. Monocots have parallel veins starting from the base of the leaf and going all the way to the end. Oh look, let's go to our right and we can see some dicots. In contrast, dicots usually have floral leaves that are multiples of 4 or 5. They have 2 cotyledon, hence the name dicot, and have taproot roots. Another difference is the veins on the plant leaves that dicots have a central vein going down the middle of the leaf with minor veins branching from it. And that, my friends, are the Anthophyta. Let's explore some more plants in Suburban Montgomery. I am one with the trees are with me. I am one with the trees are with me. I'm one with the trees are with me. I'm one with the trees are with me. Bill, you're live. Oh, hi there. As you can see, I love nature. I love these trees. I am one with these trees. This is a pine tree. It's a massive tree. It produces ovules, which turn to seeds that cluster into cones like this. All conifers have large, woody trunks like that one that's in the center. They also have these prickly needles. Ooh, that hurt a lot. But sadly, they do not produce fruit. Let's continue on our plant journeys throughout Suburban Montgomery. Shh, we're hunting wild pterophyta. I see one. Gotcha. You're coming to the lab with me, buddy. Pterophyta. This plant right here is part of the Pterophyta phyla, the second largest group of living seedless vascular plants. This phylum includes the 12,000 different fern species, and over 2/3 of which are tropical. Pterophytas have adapted to many different ecosystems. Some are aquatic, some live in the desert, or on dry rocky cliffs. A few persist in the cold Arctic desert, but mostly the modern ferns live in the tropics. Their size also varies a lot. Some can be higher than 70 feet, while others are small, like the aquatic ferns. A fern is a member of a group of vascular plants that reproduce via spores and have neither seeds nor flowers. The Pterophyta are known to have three main parts: fronds, rhizomes, and sporangia. Fronds are basically the special leaves you see on plants of this phylum. The rhizomes are the stems of the plants that grow right below the ground, and sporangia is the reproductive structure of the plant. Let's continue our journey to find the wild Lycophyta.
Bill, wake up.
Stop.
What about the Lycophyta?
The Lycophyta? Let me put on my Lycophyta finding glasses. They're scanning. There's one over there, Lycophyta. This plant right here is part of the Lycophyta phylum. The distinguishing features of the lycophytes are the arrangement of their vascular tissues and their leaves, which are microphyls with only a singular vascular strand. All of the Lycophyta are very small, none being taller than 1 meter long. Thank you for tuning in to the Bill Nye the Science Guy Plant Finding Spectacular.
Now to the ecological services. There are 4 main things we have to focus on: provisional, habitat/supporting, regulation, and cultural. Those are the 4 main services that any ecosystem provides. So some of the provisional things we have to focus on is water supply, farmland, wetlands, forests, and things like that. So I'm going to start out with water supply. And at the Montgomery Township Sewer and Water Code states that they charge $10.32 for every cubic foot. And there are approximately 1,394,064 cubic feet of water in Montgomery. And that will lead you to a result of $139,364,344. Next, we can talk about farmland. So the average farmland in New Jersey costs $12,800 per acre. And there are approximately 5,341 acres. There's also an additional $13,000 per acre because of the crop yield. So that will lead to $25,800. So it's $25,800 $25,000 800 multiplied by 5,341.34 acres plus an additional 3790.47 acres of residential land, which is also used for rural residential land, which is also used for farmland. And that will equal a grand total of $235,600,698. And with this farmland, it includes better soil, and with the better soil, the nitrogen cycle becomes more efficient, and less nitrogen is wasted from pests and anything else. Now we move on to wetlands. With wetlands, there is 2,487.7 acres, and which leads to 1,006 hectares. And that's what we got from the natural resource inventory, Montgomery Township Natural Resource Inventory. There's each acre of wetland costs an average of $54, and that leads to approximately $54,300. Insignificant compared to the other two. Finally, we reach forests, one of the most expensive and most valuable resources. So forests account for both timber, raw materials, and one of the biggest calculations that we can include is deforestation. So with deforestation, the value of forests increase so much. So initially, from calculations of statistics, we found out that each acre of forest is $277,778 per acre, and there's approximately 5,121.1 acres, and that will lead to almost 1.42 billion. The reason this is so high is because trees do so many things for our environment, including it is a huge carbon sink. Deforestation can cause extreme temperature swings, climate change, and trees often absorb greenhouse gases. So once this deforestation occurs, the release of greenhouse gases, carbon dioxide, and lots of temperature swings will occur. Next, we have residential land, and approximately there is worth $21 million of residential land in Suburban Montgomery. So if we add up all of this, we can start filling up the chart, and I'll start with the 1.42 billion because that's probably one of the biggest users in the ecological worth. Then we have 139 million, which brings it up a little bit. And you have 235 million, which brings it up a little bit more. 54,000, which probably does even less than that. And this is 21 million. I'll call it 21 million and 54,000. Next, we move on to habitat and supporting. But habitat and supporting is almost it's part of most of the other programs, so it won't really matter. So we can skip habitat and supporting. Regulation includes a large amount of it as well. So with regulation comes gas regulation and biological control and road cost, farm preservation. So I'm going to start out with the clean air and air filtration system. So we spend an average of $7,635,000 on indoor air filtration. Another $6,108,018 is spent on safe water monitoring and biomonitoring, and these programs include ASMN, AMNET, non-point source monitoring, safe drinking water reservoir monitoring, etc. And there's a whole bunch of programs that Suburban Montgomery uses to ensure that we have safe water and we take care of our crops and soil. Next comes road costs, and this is part of the New Jersey State Plan, which includes preservation and sustainability, and that leads up to almost $870 million, which is another big user. And then comes farm preservation, which is $14,202,837.80. So, yeah. And basically in cultural, it's going to be tourism and attractions, and that's kind of insignificant compared to the rest of the costs. So we're just going to fill up the rest of the chart. And about 870,000 is like right here. And then you have 6 million and 7 million. And then the rest is $14 million, and that comes from the farm preservation. So, ways that we can improve the value is by controlling deer population. By controlling deer population, we can limit the amount of farmland that's destroyed and trees that are destroyed, and that'll affect both the water cycle, the nitrogen cycle, and the carbon cycle. We can have pest control programs, which is going to have a similar effect as the deer, controlling the deer population. And last, we can have better irrigation systems. Better irrigation systems will increase our crop yield and thus increasing our ecological worth. So after actually calculating all of this, I got a grand total of $2,713,965,197.80.
Thanks, Dr. Fax. That was stupendous. It hurts me to say this, but this episode has to come to an end. We had an amazing adventure going through Suburban Montgomery, looking at all the ecological cycles, the different plants they have here, and the wonderful people we met on this journey. Please, tune in next time to another episode of Bill Nye, the Science Guy.